So in this video, I'm going to show you how I did the navigation system for my game Ant Keeping Simulator. It's a whole custom system and I'm really proud of it, so it's really cool and I'm going to show you how it works now. So basically it all relies on meshes in Blender that then get put into Unity. So essentially I have this mesh here and usually it just looks like this in the game. But then there's an invisible mesh that basically just is the same mesh but only where the ants can walk. And it's smooth shaded for reasons, but that's not that important actually. For like you to know, but only for me to know, because otherwise, if I forget that, everything breaks. But essentially, it's just a smooth shaded mesh that just has a whole bunch of squares. There's an LOD version as well, so basically this one has less triangles, so it's slightly more performant but less accurate. And I use those in these scripts here.
If you want to make games with tons of other cool people and have all the money you make go to charity and learn a whole bunch about game development, go join the Discord in the description. It's super cool there. I'll be in there teaching people like all I know basically, so we can make the game better and better and better. And then hopefully, if all goes well, I'll be able to donate all that money to charity. I mean, I'll do that also if it goes poorly. But if all goes well, a whole bunch of money will go to charity and it'll save a whole bunch of lives and it'll be cool. So if you're interested in that, head over to the description and I'll see you there, I guess. Probably. I mean, there are a lot, so I'll probably see you. Goodbye.
So we start here on the worker ant AI. If you've seen the last video on the series, then you'll see basically, then you'll know how we get here to this part of the code. But essentially we call the custom nav controllers get path. So here we have the custom nav controller, and that one has a function called get path. So this function here, or I guess it's a method in Unity, but I just get to start, the end, and then and then it outputs some other stuff. This is debug stuff, and this is just if we should be using the LOD for this. So the LOD mesh I showed you here, should we be using this one or should we be using the smaller one, basically, the less performance intensive one. So we just check if our mesh is we just check if we're in the mesh, if we're in a mesh, and then if that's the same mesh here, or if either meshes don't exist, then we just still turn nothing, just to make sure. But if both meshes are the same, then we just navigate on that mesh basically. So how the navigation basically works is we call this code here, and we put that into an array of integers. So this array of integers is just the indices of that mesh. So a mesh is basically just a whole long list of points that are connected to each other. And since they're just a whole long list of points, you can just have an index, a list of indexes of those points, and then you can get both the normals and vertices of those points, which we do here. Once we have this list, we just grab, we just put in there all of the positions we want. And here we have our custom nav mesh code. So this is like on the actual mesh. This is just a controller, so this just manages all of them. And this is for each specific mesh gets this script. So first we generate the mesh. So that's just done using this code here. This is kind of complicated, and essentially we just use the triangles to get which ones are connected to each other, which is an important thing to know. And that's put in this list of integers here. Yeah. And that's then put in a list of lists of integers. So basically you have a list of all of the vertices, which is the same as the list of these vertices. So basically we just have an index for each vertice, and then that one gets a list of themselves of which other vertices it's connected to, so the indices of the other vertices. It's a little bit complicated, but hopefully you got it from that explanation. Then I just go through the mesh. I first take all of the vertices and stuff out of the mesh, because it's really inefficient to call mesh.vertices a lot. So I just do that first. I take it out of there. And then I just check for each triangle, is this connected to that triangle? Check for each triangle. Triangle equals I. So if the triangle, which is how they store the triangles, is just a list of integers essentially. So I'm not sure exactly how it looks, but it's basically just like the first three parts of the first three, what are those called? Brain fart. First three things in the array are the first triangle, second three things, the next triangle, and then it just keeps going like that. So here I could quite easily just go, if the first one in the triangle is I, and then it just keeps going basically. So that just means that this one is connected to that one. And it's weird to wrap your head around, but basically it works. Then I just check if we've seen it before. So if we already have this in the array, then we don't add it, because then we're connecting them doubly, and that's not what we want. So that's something we make sure we don't do, and then we just add them to the list of connected vertices. Now these connected vertices we use later, and then we just do the same thing here for the LOD mesh. So it's just so we have it of both versions. But yeah, the connected vertices we use later on the get shortest path script. We also have an is in mesh script that basically just checks if it's in the mesh. If you ignore this bit, it's really simple. Like if you ignore this, this is what we usually use, but this is for the digging system, and that needs some more complicated code. So basically, we check if it's in the bounds. Basically, this is really simple. You can just look up how mesh.bounds.contains works, and then you know how this code works, basically. So my point was, get shortest path. That's the thing that returns the list of instances we use here. So in here we use this function here, or method, and that just creates a new list of integers that we're going to use as the path later. And then we do some stuff for the digging here. So just ignore this code, and then we get into here. So basically we get the closest point, so the closest index of the closest index to the start position and the end position on the mesh. And we do the same thing here. And if it's the same, then we just return it immediately, because it's no need to do anything then. And then we just clear all of these lists here, because we store those somewhere else for performance reasons. These aren't like local variables for that reason. And then we basically just use A star pathfinding to do the rest. It looks a lot more complicated than the usual A star pathfinding script, but it's essentially the exact same thing as just the one I plugged off of Google. Because why would I be writing my own pathfinding script for this? That's ridiculous. So essentially this is just the A star script with some extra stuff to stop us from reaching infinity. So in case I mess something up somewhere, I just have to stop infinity here to make sure this for loop stops before it just keeps going forever. That's a pretty effective way to make sure your game doesn't crash and you get run into really computed bugs. It's generally a good idea to show some kind of indicator when that happens. So I do that here. And that's basically it. So this is just the A star pathfinding script. A star pathfinding is not something I'm going to explain here, because it's pretty simple to implement by just copying straight off of Google and then figuring out how it works. You generally have comments, you know. So it's just this, basically. We just check. I know how it works, but it takes a long time to think about how it works for me, because it's very complicated and I'm not going to be able to explain it very well. So just look up a video about that. So I just use A star here, and then we return the path here, and that then gets used in here, which I have accidentally scrolled all the way down, and that then gets used in here, and then we have that list of indices where we just grab the vertice of that mesh, basically, and we just basically set each indice into a position and a normal. So we use the normals in order to make our ants like orient the right way on the mesh. And that's basically it. Now we have the same thing here, and this looks very scary, and I realize that this might not be the best layout for this code, because it looks more scary, but this basically just the same thing as this, but for each mesh that's on the path. So as you can see here, we have, this is one outworld essentially, so this is like a bit where the ants can walk around in outside. And of course we're gonna have way more than just this bit, right? We're gonna need like some place where they can get water, some place where they can like have a nest, you know, stuff like that. So all of those are separate bits of this code, but this code basically just glues all, like it just generates a path for each of those and then it glues them together. I have a separate script here to get the path between each mesh. So that's just a very basic script. Well, very basic. It's a slightly more basic script that it's only 70 lines long, so it's pretty basic, but it's kind of dense. So essentially it just goes through all of them and it checks if they're connected. I'm not actually sure how this works anymore, I forgot, but it does have a caching feature. So it does, like, if you already know, oh hey, from this mesh to that mesh is this route, then it just takes that route. So that's a lot more efficient, and that is basically it. So this just uses that list we get from there to do the same thing like X amount of times, and then it just does the same thing as it does here in here. So we just get the path we get the actual like path of vertices of vector trees instead of the path of vertices or like indices of the mesh. Then this script has a whole bunch of like helper methods, so like is upside down and move point as a bounds, just a whole bunch of stuff to make sure that we get close to normal. Just a whole bunch of stuff we use in different parts of the game to get stuff related to the nav mesh. Some people don't like this, like clean code people. I think this is fine, honestly, to put like a whole bunch of assistant scripts because it just makes more sense to my brain. That's generally how I code. Like this makes sense to my brain. That's what I like. I don't work in a team, so that's maybe something I'm gonna have to change later on. But that's how this code works. And now let's just go into some bits about this code. So it performed pretty well. I did something I explained in a previous video that I don't do all the path calculations at the same time. I try to spread them out as much as possible. So that improves performance a lot, and it actually performs pretty well, especially after I implemented A star. Before I was using a different pathing algorithm. I think it was Dijkstra, maybe. I think so. Not sure. That one was a lot worse performance-wise, so A star really helped. It was a really quick, easy way to change it over to A star, so that it wasn't much effort. And that's basically how this entire code works. Hopefully this helps you kind of think about like how would I implement something like this. And the reason I implemented all of this was because I wanted the ants to be able to walk on the ceiling. Because the default Unity pathfinding doesn't do that. If you don't need some like weird unique pathfinding for ants or something, just use the thing built into Unity. It's way easier. This was a massive pain to implement, so just do that, please. Also, will probably run way better. So it runs okay. It doesn't run the best. So my point was that's this entire code, and hopefully you'll now know how to code better yourself. If you want to learn how to code even better, join my community, and then you can learn mainly how to 3D model, but I'll also figure out something for coding if you want to learn that. And we are currently working on Ice Gaming Simulator, so if you like this game, then join, and you can work on a sequel. That's all going to charity. I'm not making money off of that, so just so you know, I'm not advertising you to work for free for me. You're working for free for new incentives or charity that we're donating to, so that's really cool. And they're super efficient, and they help a lot of people save lives, and that's really sick. They work in Nigeria, and they're super like effective altruism, efficiency oriented. That's really cool to me. So that was the outro. Hopefully you enjoyed this video. Link in the description to the Discord. Goodbye.